Okay, here's another problem where I'm taking a gas and I'm changing the conditions that it's experiencing. I have a 100-liter sample. I'm going to compress it down to 10 milliliters. So I'm changing the volume. Now, that might change other things as well, and that's what we're going to figure out. Now, your worksheet should say, assume that we got a constant temperature so that this process happened under constant temperature. So let's write down the combined gas law. P1V1 over T1 equals P2V2 over T2. And what does that mean, constant temperature? It means T1 equals T2, so they get canceled. Let's rewrite it. P1V1 equals P2V2. Okay, what am I trying to get here? What was the original pressure? So that means I'm solving for P1. So let's go ahead and rearrange this so that so P1, so that I know how to solve for it. P2 V2 over V1 equals the original pressure. All right, so let's deal with the pressure and let's plug everything in. Well, I'm given given volumes of 10 milliliters and 100 liters. Now, in another problem, we saw that you couldn't have the temperatures in Celsius, you had to convert them to Kelvin. Now, the reason that is because the Celsius scale has negative temperatures, and that means that the ratio of the temperatures could be different. But the ratio of volumes is not different because there are no negative values. Now, they do have to be in the same units. And since I'm giving you liters and milliliters, we need to convert one to the other. And so let's go ahead and convert milliliters to liters with our metric prefixes. And so we get 0.01 liters for that volume. All right, let's put it together. P2, that was 350 millimeters of mercury. And so the same thing with pressure, there's no negative pressures. And so the answer I get will be in millimeters of mercury. Let's take that volume 2 was 0.0100 liters. And let's divide it by the original volume, 100 liters. And so what do I get? I get 0.0350 millimeters of mercury. And that's the final answer. Okay.